7. A train travels daily between two cities. The probability that the train arrives no more than 2 minutes late is 0.45. So probability value is given P equal to 0.45. Bobby randomly selects 30 of these trains. So n is also given 30. N is not a large number. So this probability we can consider as a binomial distribution. So x is binomially distributed 30, 0.45. So the first part of the answer is find probability of x greater than 16. So this x is greater than 16. So 1 minus probability of x less than or equal to 16. We can use the table minus probability of, here the n equal to 30 and the probability value 0.45. So take the corresponding value less than 16, 0.8644. So the value is 0.8644. So the required probability is 0.1356. This is the first part. This part, Halley takes a random sample of 180 of these train journeys between these two cities. Using a normal approximation, the probability that more than k of these 180 train journey arrive no more than 2 minutes is less than 4 decimal places. Okay. Using standardization, we are going to convert this binomial distribution as a normal distribution. So convert as a normal distribution. In a normal distribution, here n is equal to given 180, and in normal distribution mu comma sigma square. So what is mu? Mu value is np. So n equal to 180, p value is, probability value is 0.45. So np value, that is mu value, is 81. Now we can find out sigma square. Sigma square is equal to np into 1 minus p. So let's find out sigma square. Sigma square value is 81 into 1 minus 0.45. So which is sigma square equal to 44.55. Now this distribution we have converted into y is normally distributed 81, 44.55. So this value is mu, this value is sigma square. Now let's see the question. Using a standardization, find the smallest possible value of k. What is k? Using a normal approximation. So when we are applying the normal approximation, always use the continuity correction. Here, let's follow the continuity correction. Let's follow the continuity correction. Continuity correction. Correction 0.5. What we are going to do? Adding or subtracting. Here, given that probability that more than k of these 8, more than k. So probability, the required probability is probability of y more than k. This value must be less than, this value is less than 0.0427. This value is less than 0.0427. We can use the continuity correction for greater than value. We have to add 0.5. We have the rules. X is less than or equal to k. We have to add 0.5. And x is less than k. We have to reduce 0.5. X is greater than or equal to k. We have to minus 0.5. And x is greater than k, we have to add 0.5. These are the rules to use the continuity correction. So now we can follow use the standardization. So z equal to y minus mu by sigma. So which is equal to k plus 0.5 minus mu value, we just now we found the mu value is 81. 81 divided by square root of 44.55. So z equal to k minus 80.5 divided by square root of this value is 6.675. Now we are converting this is into the probability. So probability of z greater than k minus 80.5 divided by 6.675. This value must be less than 0.0427. This probability we have to follow 1 minus probability of z less than k minus 80.5 by 6.675, which less than 0.0427. We can follow the table. So the required probability is 1 minus, when we subtract 9573. So when we subtract 0.9573, this value is equal to 0.0427. But our probability, our z value is must be less than. So we have to choose 1 minus 9582. 0.9582. This value must be less than 0.0427. Here the required z value is 1.73. So here z value is 1.73, because in this case 1.72 is not possible because it is equal to our required probability we need less than. So z value, suppose z equal to 1.73, our k value is k minus 80.5 divided by 6.675, which is equal to 1.73. By cross multiplication, so k minus 80.5, which is equal to, when we are multiplying 1.73 times 6.675, after adding 80, this value is 92.04775. We have to write the round of value. So k equal to 92. This is the required answer.